Okay, couple of things we have to simplify this expression, and then multiply two numbers here using scientific notation. So the first one, we have, let me go up here again. And 6, x to the 4th, and the negative 3rd. We could separate out variables and the numbers. We said that's 4/6 times x to the negative 2nd over x to the 4th times y to the 5th over y to the negative 3rd. Necessary to do this, but it's not a bad idea when you're first working. Now 4/6, of course, reduces to 2/3. Now, what do we do with an x to the negative 2? Well, x to the negative 2 is the same as 1 over x squared. So this is like squared times 1 over x to the 4th. And this is like y to the 5th over 1 over y cubed. Now, you don't necessarily go to all this trouble when you write these out. You just kind of flip things from numerator to denominator and vice versa. But I want to be sure we understand why we do that. First of all, we multiply these two fractions, multiply the numerators, we get 1, multiply the denominators, we get, well, x squared times x to the 4th. For dividing y to the 5th by 1 over y cubed, it's the same as multiplying y to the 5th by y cubed over 1. So now we can say we have 2/3 times 1 over x to the 6th. And everybody understands, I think, why x squared times x to the 4th is x to the 6th. And then times y to the 8th. Because y to the 5th multiplies the y cubed, you could make that y to the 5th over 1 times y cubed over 1. 1 times 1 gives you 1, so you don't need to write that in the denominator, but there we have. So now we put this into one term. And again, y to the 8th means y to the 8th over 1. So we multiply numerators and we get y to the 8th. And we multiply denominators and we get x to the 6th. And I guess we go one more step. That would be 2y to the 8th. Six. Now, if we do this a little more efficiently, say that well, x to the negative 2 is the same as a 1 over x squared. So we can say that we're going to have a x to the 4th here and an x squared here. X to the negative 2 in the numerator becomes an x squared in the denominator because of all this. Okay. The result of writing out the x to the negative 2 is a 1 over x squared, and then multiplying that by 1 over x to the 4th gives us the same thing. So we have to understand why it is we do that, but we can, if we try to remember what the definitions are, we can kind of bypass that and think that the negative exponent in the numerator is going to give you the positive exponent in the denominator and vice versa. Okay, then y to the fifth is still going to be there. But the y to the negative 3 in the denominator becomes a y to the third in the numerator. Why does it do that? Because of this rule. Now, ideally, you should be able to work it out like this and show why everything works. Okay? Most people will just cut to this method, and that's okay. But I do encourage you to understand why the method works. And there we have the same thing we got when we did it, all the steps. Okay? Now we at least want to write out this intermediate step here. Because if you bypass this, it's real easy to subtract that 3 from the 5. So, okay, it's just real easy to see it wrong. You want to write it out explicitly in at least 3 steps. So as to avoid costly errors. Okay. Okay. So that's it, but there's one more thing we can do with this. Okay, this is one way of writing it. And this way is writing it without any negative exponents. Okay. Now the other way of writing it to write it without any denominators, except of course 6, you're gonna have the 2/3. So that's going to be the same as 4x to the negative second, x to the negative fourth. And your x to the fourth in the denominator will become an x to the negative fourth in the numerator. Then you're going to have your y to the fifth, y to the third over 6. And that's 2/3 x to the negative sixth. And you see that this is the same as this or this. Your x to the sixth in the denominator would become an x to the negative sixth in the numerator. And the way we got to that is the x to the fourth in the denominator becomes an x to the negative fourth in the numerator. And the y to the negative third in the denominator, of course, becomes the y to the third in the numerator. Now, people did well on this assignment. I think everybody got pretty much all the problems, mainly, maybe with the exception of one in one case. And I don't remember who that was, but it was just a simple little error. And I put a note in the document explaining that, but it was one of the early problems and they got all the later problems right. So I figure everybody knows these rules. Now we have 6, and then we got that followed by 1, 2, 3, 4, 8 zeros. So that's 6 million. Sorry, 600 million. 6 times 10 to the 8th multiplied by 3 with 4 zeros in front of it. And that's going to be 3 to the negative fifth. 3 times 5th, negative 5th. Six times 3 multiplied by 10 to the 8th times 10 to the negative 5th. And that's 18 times 10 to the 3rd. Now, there's a temptation to stop here, but 18 is not between 1 and 10. Okay? It's got to be at least 1, and it has to be less than 10. So 18 could be written as 1.8 times 10. And you still have your 10 to the 3rd. And then you've got to understand that 10 times 10 to the 3rd is 10 to the 4th. Because 10 to the 3rd means 10 times 10 times 10. Get another 10, you got 10 times 10 times 10 times 10. If you want to think of adding the exponents, you could remind yourself that 10 is the same as 10 to the 1, and you add your exponents. Okay? Make sure details. You get one. So again, with practice, scientific notation and these expressions with exponents, it just takes a little practice, sometimes a lot of practice, and you're going to get them. Okay, now you know how to deal with exponents. Let's say you have an expression like x squared x cubed minus 5x squared plus 6x minus 9. Can you multiply that out? Well, I'm going to do it for you. And I'm going to give you a couple more to work on, okay? Now, this means x squared is multiplied by every term in the parentheses. That's called the distributive law of multiplication over addition. We usually just say the distributive law, but there are a number of distributive laws in mathematics, okay? This is the only one you're going to be dealing with now or in the near future, okay? What this means is x squared multiplied by x cubed minus x squared multiplied by 5x squared plus x squared multiplied by 6x minus x squared multiplied by 9. Notice we have our x squared here in front of every one of these terms. Okay? Now take a minute and simplify this. You know how to do it. I'm going to step out for just a minute because I apparently am out of chalk that I can actually write with. I'm going to go grab some and haul across the way. Well, now what's x squared times x cubed? Well, you have a rule that says when you multiply the same number, the different powers, you add the powers. That's because this means x times x. This means x times x times x, which gives you x times x times x times x times x. That's 5 of them. Okay? So this is x to the 5th. Okay. Next, we have x squared times 5x squared. Well, we usually don't, but we could rearrange this multiplication as 5 times x squared times x squared. Okay? Because we have 3 numbers multiplied, we can multiply them in any order. And then this could be 6 times x squared times x. And this is just 9 times x squared. there's nothing we can really do with that. We just have two terms, but we usually put the number in front of the variable expression. So just to be grammatical, put a 9 in front of x squared. Well, now, that's going to give us x to the fifth. Well, x squared times x squared. You got two x's multiplied by two x's. That's going to be 4. You got 5x to the fourth. And this is going to give you 6x cubed minus 9x squared. Okay. This step in here is more or less optional. If you can see, well, I've got an x squared, I've got to multiply it by the x squared, and that's going to give me x to the fourth. It's not absolutely necessary to do this, but when you do that, you ought to think that, yeah, I could do this, but you just skip to this. Okay, we'll give you another one. Three x cubed times x squared plus 5x minus 9. Okay, so we have three x cubed multiplied by x squared plus 5x minus 9. That means we're going to have 3x cubed multiplied by x squared plus 3x cubed multiplied by 5x. I'll say minus 3x cubed multiplied by 9. See the pattern? Put a 3x cubed in front of each of these terms. Okay? Then, knowing the rules for exponents, we easily say, well, x squared times x cubed is x to the fifth. X cubed times x is going to give us x to the fourth. And 3 times 5 is going to give us 15. And then 3 times 9 is 27. And we don't have any x terms on there, so just 27x cubed. Okay? So this is all pretty straightforward. You learn to get this with just a little practice. It won't take you long. Not going to use any numbers. I'm just going to use x and y, a and b. And I want to multiply x plus y by a plus b. But what this means then is x plus y multiplies a, and x plus y multiplies b. So far, it's not really different from what we did here or here. This thing's out in front, it multiplies a plus b. So we multiply this thing by a, and we multiply this thing by b. That makes sense? Well, now there's another step to it. If I multiply this plus this by a, what does that mean? It means I've got to multiply this by a and this by a. So that's x times a plus y times a. X plus y times a means x times a plus y times a. And then it's x times b y times x. So I'm gonna ask you to write this one. I'm gonna have some numbers on this. I'm gonna ask you x plus 2 times x plus 3. Yeah, just like this. Okay, so what we get here, and I do want people to follow all the steps. Okay, think, over here, whatever was out in front, multiplied every term. Okay? Whatever's out in front here, multiplies every term. So what's out in front? X plus 2 is out in front. And it multiplies every term. So we have x plus 2 times x plus 2 times 3. Okay? X plus 2 multiplies this, and it multiplies this. This times this, added to this times this. And then multiply this x by everything in here. So we get x times x plus 2 times x x times 3 plus 2 times 3. So we end up with x squared plus 2x. Now x times 3, remember, grammatically, we want to put the number in front of the variable. So we write this as 3x plus 6. And since 2x and 3x gives us 5x, we got x squared plus 5x plus 6. Now, if you got down to here, that's all I had demonstrated, and I didn't necessarily expect you to go into this next step, but now you'll be able to do that. Okay. Okay, so now I'm gonna let's try this. We'll put it in front of this. We'll put it in front of this. The first instance. What you want to do, this is not 2x, this is x plus 2, okay? You put x plus 2 in front of x squared. Can you do that? Just write x plus 2 times x squared. So that's what you were thinking. But yeah, that's not 2x. Okay. Then x plus 2 times 2x. And how do you do x plus 2 times x squared? See what I do.
Right.
One and 2 in front of that. You multiply x by x squared, you just get x cubed, right? Then separately, you multiply the 2 by the x squared. Apparently, I'm still recording. It's okay, nobody said anything. Okay, so what do we have? We have x plus 2 times x squared plus 2x minus 4. And we're going to x plus 2 by 2x. Leave myself to write that out. We have x plus two, then times x, and I better write that. That's right. Still not great, but I think. Okay, then we have x plus two times x squared. What do we do with that? Well, x multiplies the x squared, which gives us x times x squared. And two multiplies x squared, so we do 2 times x squared. Now, if you're a little shaky on this, I wouldn't write x cubed here. I'd write literally x times x squared and 2 times x squared. In the next step, you can write the x cubed. X cubed would be right, but don't think about adding the exponents at this point. Think about writing this times this plus this times this. And then here, well, x plus 2 is multiplying 2x. So x multiplies 2x and 2 multiplies 2x. So we have x times 2x plus 2 times 2x. And then what do we have? X plus 2 multiplies -4. That means we have x times -4 plus 2 times -4. Now we can go ahead and simplify these things. And once we get good at this, yeah, we can skip this step here. I don't recommend doing that for the first assignment you do, though. I recommend that you write everything out so you remember what's going on at every step. Okay? Don't shortcut anything. Reinforce all the principles. Okay, x times x squared, we know now to be x cubed. 2 times x squared is 2x squared. X times 2x, well, we can see that x is going to be multiplied by x, and we're going to have the 2, so that gives us 2x squared. 2 times 2x is 4x. And then x times -4 is -4x. So adding a -4x is the same as doing -4x. And 2 times -4 is -8. Now we have x cubed. We have a 2x squared and a 2x squared. Well, that makes a 4x cubed. We have a 4x and a -4x. Well, that's 0, so we don't have to write any x terms. But then we've got our -8. There's our final result. See what you do with this one. Okay, everybody is doing pretty well. Okay. Now, some of you wanted to flip it and multiply x plus 4 on this side by x squared plus 2x minus 2. And that's perfectly legitimate. It's legal because this is multiplied by this, so you could multiply this by this. Okay, either direction. But I'm going to do it just the way it's written out because sometimes you're going to have, okay, this is a trinomial. It's got 3 terms in it. And this is a binomial. It has 2 terms in it. What if you had a trinomial times a trinomial? But if this had 3 terms in it, there'd be no point flipping it, okay? But if you flip it, it looks more like this, and that's fine. Okay? I'm gonna do it this way. It's about x squared plus 2x minus 3 multiplied by x x squared plus 2x plus 3 multiplied by 4. This thing multiplies this, and it multiplies this. Okay? Then we have x squared times x plus 2x times x minus 3 times x. This times x, this times x, and this times x, right? And then we have x squared times 4, this times 4, and 2x. And minus 3 times. Okay. So now what do we have? We have x cubed. We have 2x squared. We have minus 3x. And we have 4x squared. That's 8x. And minus 12. Once we've written this out carefully, then it's real easy to do the multiplications. And again, I recommend you include this step instead of just skipping to this one. But those who did skip to this one appear to have done it right. And that's good. You'll understand the rule better if you follow it literally right out this step. Okay. Now, it's going to give us x cubed. We have a 2x squared and a 4x squared. Okay. So I got to put another line around this and this. So another line beneath this. Okay. So that's going to be plus 6x squared. Squared cannot see. Okay. And then we have a negative 3x and an 8x. So put a circle around that now. And that's going to add up to 5x. We have negative 3 of them, 8 of them. And then that just leaves us with a negative 12. Okay. And that's what I'll bet you will get. Okay. Even though 2 out of 3 people decided to put this first. Still comes out the same. However, we don't have time to do it. But you want to think a little bit. What would you do if you had x squared plus 7x minus 8 times x cubed plus 2x plus 6? Well, it should be obvious what you would do. You'd multiply this by this, then you'd multiply this by this, and then you'd multiply this by this. Now, if there's some reason you think it'd be easier to put this one to the left, to put these in the opposite order, but since they're both trinomials, it wouldn't be any easier, and it wouldn't be any more familiar. So this would be more familiar. If you put this over here, it would look more like this. That would be okay. Sometimes you get this, and then what are you going to do? Fair enough? Okay, well, your assignment next time is on polynomials. And it'll be due tomorrow evening. And if you can do everything we did here, you get a little more practice doing it. Make sure you write everything out carefully. That's the way you learn it, and that's the way you remember it. And write it out without having to look at a bunch of other stuff. Okay? As soon as you get to the problems that don't have videos, stop looking. Then if you have to look look and take careful notes and see what it is. You should have understood that you didn't. So the next one, you don't have to look. Okay? Okay. Well, y'all did well today. So have a good day and I'll see you Wednesday.